Hi, I will get started in my chapter review. So we're gonna define and list some of the following things. So the first one is natural numbers. So natural numbers would be like numbers that you count, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like I have listed. Also, whole numbers is just when you like add the zero and then you start counting all the way to whichever number. Integrate are concept of being in debt to introduce negative numbers. So it would be like like whole numbers are positive numbers. This would also include negative numbers as well as positive numbers. Radical numbers, these numbers are represented by division of two integrants, such as like 1.5. So it would be like dividing a fraction. Irrational numbers are numbers that are not represented by a rational number. They can be expressed by non-terminating and non-repeating decimals, such as like pi, the square root. Yes. So I couldn't find the complex numbers in the pages. Associative properties are numbers that can be grouped in any order when adding or multiplying and result in the same. So that would be like when you're adding A plus B plus C, you would assemble it in a different way, which will equal in the same result. So as you see, like B plus C is multiplied, over here is A plus C, and the end result, it would be about the same. Same with this one. So here, let's say you're multiplying, with multiplying, it would give you the same result. Commutative properties, they state numbers, but they're multiplied in any order. So in addition, it would be like 1 plus 2, or 2 plus 1, it would still equal 3, right? The same with multiplying would be 1 times 2, would be 2, but 2 times 1 would also be 2. So it would be about the same. So with distributive properties, multiplying over addition to sum the product or products to sum. So this would mean like A plus AC, you would distribute it in a way that it would to make it a sum. So here it says multiplication over addition. So instead of adding everything together, you're going to be multiplying everything together to give to change the sum of the product. Absolute value, that would be the non-negative value of a number with regards of its sign. So order of operations, pandas, so it would be like parentheses, exponents, multiplication, division, addition, and then subtraction. So you would be working from left to right. So Gemma will be like grouping the numbers, exponing an exponent, multiply, and then division. So, and then adding and subtraction. So, in a way, these two are very similar because using these two operations, you are simplifying the problem, right? So finding the distance between negative 3.2 and 8.2. So I started off like doing this on my laptop, and I figured out that it was like a little too hard to like type everything. So some of my work would be like already typed, and then later on you'll see that I started writing it just because it started getting a little too like complicated. So with this, we're gonna be using AB. So our A would be this, and it would have to be negative. So we're gonna do negative 3 minus 88, right? So if we subtract these, it would equal 12, right? So that would be 12 is the difference between negative 3.2 and 8.2. So to name the properties illustrated by equality. So this would be like 3 is 8 plus B. Equals 9. Sorry, I'm mixed up. So this would be, oh, it says name the property, sorry. So this would be a commutative property, right? To simplify the following expressions and stated properties used in simplifying. So here to simplify, we're gonna simplify this, right? So with PEMDAS, we are going to do our exponent first. So this would be 4 times 4, right? Oh, not, sorry, PEMDAS would be P parentheses. So we're going to do our parentheses first. So A has an exponent of 2, a power of 2. That would be 64. 3 has a power of 2. That would be 9. So then we're going to subtract 54, negative 9, because these are in our parentheses, it would be 55. So after that, we will do our exponent. So where do I have that? Oh, over here. So it would be, so it was 2 with the power 2. This would make it 4. And then we would have to, we're going to multiply 9 times 4, 36, plus 51 would, plus 55 would equal 91. See, this is where I realized that I need to write things down because it was getting a little too long. So with this, we will be starting right over here. Just because it has an exponent is the first one, we're going to do left to right. So 9 with the power of 2 would be 9 times 9. It would equal 81. Yeah, it would equal 81. So then here we're going to multiply. I think I wrote this wrong. We're going to multiply our 3 times 7. Which here the 7 needed to be here as well. 3 times 7, it would be 41. So then we would forget about this. So now we would move on to this one. So A has a power of 2. That would be 64. So as we're doing this, we're somewhat like simplifying our equations to make it more simpler. So now, so we're going to do left to right. So now we're going to do our 9 exponents has a power of 2. So that would be 31 actually. 81, sorry. 81. And then, so now that we have all of these, it would be, now we're going to multiply 84 times 81. It would give us 5,000, it would give us 5184. So next, we are going to multiply our rest of the numbers. So, 3 times 7 would equal 42. And then, yeah. So, and then we still have the exponent here. That was a power of 2. That would be 64. So while we're doing this, we are breaking everything down. So here we have 81 take away 42. That would equal 39 plus 5184 take away 42 plus 64. So we're going to add these two together, which would equal this, right? 5224. And then we are going to subtract, which will give us 5199 plus our 65 would give us 5463 as our answer. Yeah, so as I was doing this, I realized I should have typed it. I should have just wrote everything instead of doing that because it was just a lot. Okay, so with our next one, okay, so for 6, I scribbled a little bit, but we're going to be working with our parentheses first. So we're going to do our exponent first. So 4 to the power of 2 would equal 32. And then 2 times 6 would equal 6, correct? And then we would put everything together. We're going to do adding first. So 32 plus 7 would equal 39. 6 negative minus 6 would equal 0. So this would equal 39. Okay. So over here, we're going to simplify this. So 3 to the power of 2 would equal 9, would be negative 9. Plus 4, so we would have to subtract since it's a negative and a positive, it would equal negative 5. So with this equation, it says we're going to put our x, it's going to be negative 2, right? So I should have put a negative here, but negative 2 times negative, oh, okay, I see what I did there. Sorry. So it would be, our exponent would be 2 to the power of 3, that would equal 8. It would be negative 8, correct? So then here, and then over here, we have 5, we have 5x. So we would have to make that x into a negative. Sorry, I should have put negative here too. It would be 5 times 2 would equal, 5 times 2 will equal minus 1 will equal 10. So here we have, so negative 2 times negative 8 would equal 16. Since 2 negatives make a positive, here we have positive times negative, it would be negative. So 5 times 2 equals 10, and then 1, right? So 16 minus 10 would equal 6, minus 1 would equal 5. Okay. So to move on from that, it says the product of exponents is to simplify all the numbers first. The quotient rule of exponents is to divide the numbers with the same base. The power rule of exponents: when a number with an exponent is raised to the power, the exponent and the power are multiplied together. The definition of power integer exponent means a positive integer tells you how many times to multiply itself. The definition of negative integer exponents tells you to times the reciprocal of the base by itself by a certain number. So the power of 0 properties of exponents is 1. The power 1 property of exponent is still 1. When does the distributive power apply to terms with an exponent? An exponent is in a single term in parentheses, but not multiplying term. Yeah. So here is where I just started doing everything by hand. So as we just went over the rules of exponents. So here we're gonna try to simplify things in a way that becomes easier, right? So here we're gonna break this down. So here we have a negative 5a exponent of 2b, exponent b has an exponent of 3, 2. So here we're going to we're gonna make the 2 into a fraction, so it all just comes together. So we're gonna do 5a times 1 equals 5, and then we're gonna bring over our b3 over here. So same here, we're gonna bring down our a2 right here. So now it says 5 has an exponent of 2. So that's going to be 25. Our b has an exponent of 3. So we're going to multiply 3 times 2. It will equal 6. And then we have our a. So 2 times 2 will equal 4. Okay. So here's when I kind of started getting a little complicated. It started getting a little complicated, and I tried. So here we're going to simplify this again. So we have a 10 x and a half y. They take away 1/3 exponents. So what's hard about this is breaking everything down. So here it says that x and y equals 0. So we're just gonna pretty much turn them into zeros, right? So where's my pen over here? So here we have a y. So what? So we're gonna simplify it. So 10 x and a half. We are going to simplify this with this, and it would bring down the 3.5 and sorry, what? Oh yeah, so since the x and y equals 0, it will cancel out this, right? It will cancel it out. So now we have, as we do that, we're gonna focus here. We're gonna start canceling. So as we cancel down, we're also gonna try to break it down. So canceling, as we cancel 2y with the exponent of 1.5 plus our the way we simplified it was dividing. So they have the same denominator would be 5. So then the 10 would be divided by 5 would equal 2. 5 would equal divided by 5 would equal 5, right? So then we're going to simplify it even more. So it would be 2, 5, and then as we simplify, things get canceled. So this is going to get canceled. And we're going to start moving things around. So this is pretty much the same thing. Since it's negative, we are going to make it into a positive because timing everything. And then our answer would be this. Oh, shit, this pen. Shoot. So, simplify without a calculator. I don't believe this. This is undefined. You cannot simplify it. So, this term means the square root of a number. The 3 means the square root of 3. The 4 means the square root of 4. How do we rewrite the radical notation in an exponent? So here we have b square root of 9. So we would just move things around. So this would be like multiplying, right? So we would multiply a times b times x. How and why are simplifications of this square root and with square root similar but different? So both are linear, which is good, but x is times while the value is negative. Combine the following expressions. So here we're gonna do is where's my pen? So we're going to break things down, right? So here we have 3y. So to break this down even more, it would be 3 to the power root of 3. We have 5. To break this down a little more, it's gonna be 5 to the power of 3 with our y plus yeah, we're gonna break this down. So we're just moving things along. It would be 4 to the power of 3 with our y. And then, so we're gonna break it even more down, right? So it's going to be 3 times 3, 5 times 5, plus 3/4 in our y. So 3 times 3 equals 9. Negative 5 times 5 equals negative 25, plus 13 in our y. So now we're going to add these two, we're going to subtract 25, take away 9, and then we're going to add our 12, and it's going to equal this. What does rationalize the denominator mean? This means by removing the radical expression of the fraction by the denominator. Why is rationalizing denominators? Why do we rationalize denominator? It means that we just simplify it, right? How do we rationalize the denominators that are monomials? X, we multiply the numerator and the denominator by the expression to take away the radical denominator. So this is how we make it simpler. How do we rationalize a denominator that are binomial? So we're gonna do about the same. So we're gonna multiply both the numerator and the denominator by the denominator. Okay, so we're gonna rationalize this. So here is our whole equation, right? And then, so the way we do this is we're gonna try to have the same denominator. So we're gonna divide this by 4. It would equal 4, so it would be the same. So we're gonna combine this whole thing together. So now that we combined it, we're going to divide our factor. So 8 times 4 would be 32. And then it would be like there was a 1 here. So we're going to put an 8 here. And then we're going to bring over that square root of 3. So here we're going to do the same. We're going to multiply 4 times 4 equals 16. We're going to do the square root of 3, would be 3. And we're just going to keep doing the same thing. So this top part is fine. And then we're going to subtract, and it would be 13. So how do we identify the great common factor? Is by listing all the factors of all the numbers. How do we group? How do we perform factoring by grouping? Is group the first two, then the last two, and then factor out the great common factor, and then factor out the binomial. So here, how do we use the FOIL method? So first we would multiply, and then do the outside, the inside, the last, and then we combine everything together. The difference of squares. So the difference by square would be, this would be our whole equation, and we would just break it down. So A has a power of 2, so we would put an A here and an A here. B has a power of 2, a B here, and then another B here. The sum is about the same thing. So with our sum, it would just be working backwards. So here would be like our starting point, and so we have A here, and A here, a B here, and a B here. So this would mean that we would put the 2 here, so it would equal about the same thing. Once we work to break it down, the perfect square, this would be like an A2 plus 2AB plus B2. Our perfect square trinomial would be A2 plus AB plus C plus 2 plus B plus A plus C, our difference of cube 3. So this is a little different, but it would be a polynomial in forms. So we have a 3 here, so we would write AB once, and then we would write it in a different way. So if we were to put all of this back, it would be this. The sum of cubes, it's about the same thing as this. Instead of the difference is that this is subtraction and this is adding, right? So our factor of each expression completely. So the great common factor would move to the trinomial, then the difference. So it's just an order way of doing things. So here we have 3x with the power of 2 minus 48. So here we're going to do is we're going to break it down. So here we have a 3. We're going to put our 3 here. We have x in a power of 2. So we were going to put an x here and an x here. Right? So the way we do this is we're going to break it down. So breaking it down means, so we're going to bring, like I said, we're going to bring our 3 down, our x here and x here. To make this 16 be even more broken down, we're going to break it down to 4 and 4. So it equals. So if we were to put all this together, it would equal this. So with question 14 is the same thing, right? So we have our 10x with the power of 2, negative 2, sorry, take away x, take away 12, right? So as we break it down is, we're gonna put our 10 here. To break it down even more, we're gonna make it into a 2. So if we have a 10 here, we're gonna put a 5 here. So 2 times 5 would equal 10. So here would be our 10. We're gonna put our x, our 2 behind our 2. We're gonna put our x and another x here. So this would be, like I said again, this right here would be our 10x2. So our 7. Since we have our 14 here, we're gonna like break it down even more, right? So 7 divided by our 2 would equal 14. So if we were to look back, so we would since we have our 2, so since if we were to multiply our 2 times our 7, it would equal 14. So it would be like rewriting it, right? And then our 15x take away 21. So as we're going on, we are breaking it even more. So as we're breaking it down, we have 5x plus 7 times 2x take away 3. And if we were to put all of this back, it would be 10x2, our x, and then our 12, right? Because we multiply these. Yeah, so we're gonna do the same thing here. So we have 24 x exponent 3. So this would mean that we would multiply our 3 6 times. So it would be like 3 times 6. It would equal 24. We're gonna bring out our 18. So then we're gonna break it down even more, right? So as we're breaking it down, it would be we would divide 81 divided by 3 to get that 27, right? And then to break it down even more, we're gonna do our 3 divided, we're gonna break out our 8 by, it would be like dividing 8 by 3, it would be 2x, take away 3, over here 2, we're gonna break down our 27. So our 27 would be 4 x2 plus 6x plus our 9 plus our 9. So what does the factor represent? It represents the part of a fraction. So how do we add and subtract the fraction with the same denominator? It would be either you add or you multiply and then you keep the denominator. How do we add or subtract the fraction with a different denominator? So you either add or subtract with a different denominator by the least common denominator. How do we multiply factors that in the denominators have common factors? With these common factors, we will reduce them. What are our complex factors? Factors with numerators, denominators, or both. How do we simplify them? There's two ways. We could simplify or divide. So it would be, by simplifying, I mean making the numbers smaller. What are our radical expressions would be our two polynomials. So here are and how do we determine dominant restrictions for radical expressions, real numbers, cause them to be undefined. How do we add or subtract radical expressions with the same denominator? Is we either add or subtract. How do we add or subtract the radical expressions with different denominators? We find the LCD and redo and multiply and redo and rewrite with the LC. How do we multiply the radical expression? Multiply the denominator to get the product. How do we divide radical expressions? Multiply the radical by the reciprocal. Perform the indicated operation and simplify the dominant. So a good way to do would be like simplifying would be like break it down. So here we're going to rewrite everything, right? And as we rewrite everything, we're going to see what's the same and we're gonna like take it apart, right? Because yeah, we're gonna take it apart. So as we're here, we are gonna combine everything together. So we are gonna combine, so you see these two are separated, like it's multiplying them. We're gonna combine our whole equation together. And then and then as we combine it, we're gonna cross things out. So as we broke it down, we have 4 times 4 times 4. Since these are the same, they exit each other out. So we are left with our 2x take away 8 by 3. So with 17, like it's kind of messy. So what we're gonna do is I rewrote it here for us, and then we're gonna distribute, right? So we're gonna try to make things even as possible. So then later on we can exit things out. So as we combine everything together, we are going to exit out our 2. So our 2 exits out this one. They all exit each other out. So we are left with this.